Hello, and welcome back to Coding Bootcamp's Introduction to the Python Programming Language. The last video, we covered an introduction to Python, and now in this video we're going to be using Python. Alright, so let's get started. First, the objectives of this course. This session will cover executing Python programs from the command line and talk about some of the command line options as well. Talk about environment variables and a bit about creating Python GUI applications, graphical user interfaces. And at the end, we will briefly discuss the Python standard library. So let's pull up a command line. Now, if you don't know what a command line is, it's referred to as a shell also, or a terminal, which is a shell program running inside of a terminal or terminal emulator. And you probably should get used to using one. You don't need one for this course, just go ahead and watch me do it, but it's a good idea to try to do as much as you can from the command line, because we'll be using editors and other integrated development environments and even coding online on web pages, but it's good to get familiar with the command line. So pull one up. That's what we'll do. That's what I'll do here. Pull one up and so you have a prompt there. Let's make it a little bigger. Okay, so let's type in Python and see what happens. Let's say -v to show the version. Hey, look, we have Python installed. Wow. So where are we running it from? User bin Python. Okay. User. So user bin Python is symlinked to Python 3, which we can see by running our version. So this is an command line option. -v, we gave it the -v switch, so it'll print off the version. So we can add a path variable to our shell environment. If we don't have Python in the path, then we can add a path environment variable to point it to where our installed version is. But if we look at my path variable, remember let's see here. Got to keep my screens up to date with what I'm doing here so you guys can see what I'm doing. All right, so you can see we listed I said type Python, and it told me it was hash to user bin Python. So now if I do echo path, now I'm in the shell, remember. This is not Python yet. This is just shell scripting, just shell commands, which also you could think of as operating system commands. So my actual Python installation is user bin Python, and I'll print out my path here, and you'll see we separate here by colons. Then I have the first place it will look for is in yarn. Applications install their own paths into the path variable. So somewhere in here should be user bin, user local bin, user bin. So it's in my path, so it's working. All right. So now let's create a file and see. We have an example file, so we can remove it. Now we'll create a new one. We give it a py extension. Okay. And that's the standard extension for Python programs, .py. So we can run this program. See, there it is. Now if we list it out, there's nothing in there. So now if we try to run it, then nothing happens. So let's try to edit that file, example.py. All right, shall we? So let's look inside our editor, and we'll type in print hello world. All right, now we save it, and we come back, and now we can run it from here. I'm using Visual Studio Code, and if you can run files directly from the IDE. This would be an integrated development environment, Visual Code. So there's a little button for running it. So I execute it. It actually opens up a shell. It executes it. You can see it gives the full path to the Python executable. And runs the absolute path to the file. And you can see it executed and said hello world. That's the output. Okay, so here's our shell prompt. Here is our Python command. Here is the file we're giving it to run. And here is the output. Pretty simple program. It's pretty much everybody writes this program the first time to test it out, right? Hello world. Okay, so moving on. There are a bunch of Python command line options. We already saw the -V, but let's try a few more. We can give it a -D to show debugging output as we're coding, or actually as we're in the environment. So you'll see here in a second, we're going to open up Python interactive environment. And when we do that, it can help in debugging. We can also create a bytecode file, PYO file. It's a compiled file because remember Python is interpreted. But you can also generate the bytecodes and run those files, which would save the interpreter the time for compiling it. Make it a little faster. So you can print off the verbose output. That's pretty verbose. So you can see there's all kinds of... It does all this stuff. The first thing it does is it's telling you what it's doing. Importing frozen import lib, then it's importing imp to do the importing. The first thing, then after it gets ready to import, the first thing it really imports is sys. Some warnings and more importing stuff to really get ready for importing. So it does all of this other stuff here, and then finally you will get a REPL prompt. This is also a command line prompt, but now we're inside of Python. So now we can execute commands. Print hello world, just like in the last example. Just like in our program. Okay, so we can exit by typing exit, I think. Is that a function? And since we had verbose on when we entered in, it also told us what it destroyed and cleaned up and before it actually exited. So now we're back to the command prompt. Moving on to the Python command line options, we can import a module with -m. So we can say perhaps Python -m, give it a module. We could say HTTP. That's server. So now we're actually running a web server here at this address. So here we are. Now we get a directory listing. We're now running localhost port 8000. I don't know if you can see that, but that's what it says. And here's our example file that we created, print hello world. I know it's probably kind of small, but I'm just giving you an idea here what's going on. So that's the -m switch. You can, now this is the first switch we tried, Python. Row switch. We can print quiet. So now if we can Control C to escape that web server. Now if we just type in Python, remember before we typed in Python -V, and it just told us the version. Now if we just type in Python, we'll go right into the prompt without the, we also typed in small v, and it gave us all of the verbose instructions it went through and imports it made while it was creating our environment. And we exited out and it cleaned up. Now the same thing will happen when we do it here, it just won't tell us. So now it's done all that same stuff and we exit out. It's also cleaning up, but it's not so verbose. And you didn't see most of that because I didn't have the terminal on for you. That's disagreeable. So remember we tried the version, it printed that. We had small v, which entered our environment, our interpreter. This is called the interactive interpreter. So now we have verbose import and verbose cleaning up. But if we just type in Python, it does all that, but it's not so verbose. So, and also the -q switch does quiet, doesn't print our header to tell us, the version and help. So Control D to exit, or we can type in run the exit function. Okay, so we can also list all of the command line options with -h. And now onto the environment variables. There's 4 of them we're going to discuss. Python home is used to set a alternate home search path, a alternate module search path, where to look for libraries. The Python path is, if we look at my environment, we can see if there's any Python environment variables. Python startup is set to nothing. So let's create a Python path environment variable, and it will tell Python interpreter where to locate the module files imported into a program. So if we say Python path equals, let's say, temp, then we could put some modules inside of temp, and we could import them from there. Now, if we want to create a Python startup, then we can point to a file that contains the Python startup environment variable will hold the path of an initialization file containing Python source code and executes every time you start the interpreter. So we could set it to our export .example, right? Now we see it's set here. Let's get it. All right. It's set to our example file. So, and remember our example file is just says print hello world. But now since we have this Python startup, when we execute Python, it will execute this file for us. So this is our, you can see hello world. It executed that as we started the interactive interpreter. So that's our Python startup environment variable. All right, so creating GUI applications with Python. There's a few ways to do it. Here's 4 of them. You can use the TK toolkit, TK interactive. It's a Python interface for the TK GUI toolkit, and it comes with Python. WX Python is also an open source interface for WX widgets, and PyQt is also a popular cross-platform Qt GUI library. Python FLTK, a Fastlight toolkit, has cross-platform windowing system. Okay, standalone versus web-based applications. Standalone applications are traditional software that's installed on each client system. An example of a standalone application would be Microsoft Word. And if you want to use Word, you need it on every computer you're going to be using it on. So if you have 100 people in your office and each person runs Word, then you got to give Bill Gates $199 for each person. But if you have a web-based application, then each person just goes to the website and uses it either online as a SaaS, software as a service, or maybe they just download it. This would be an example of a thin client like Google Docs, where all you need is a browser. The Python standard library is a library available on any machine where you have an application using the specific language. Here the specific language is Python, and the standard library ships with Python. And it's going to have a bunch of functions that we can use in our code. So the standard Python library has two things: the built-in functions like len, min, max, and also the imported modules in the standard library like math. So important built-in functions, there's built-in operators, and, or, not. Comparison operators, greater than, equal, less than. Length, using the len function on any iterable objects. Like lists are iterable, strings are iterable, dictionaries. Range holds all numbers from 0 to x. List creates a list. Min and max give the least and the greatest values, the minimum and the maximum. Round, absolute value, power, sorted. Type gives the type of an object. So we can perhaps have a look at, remember, so you get into Python, you type in Python, and now we're in the interactive interpreter. So we can say 1 and 2. Says 2. We can say 1 less than 2. True. We can say, what is the length of the string 1? It's 1. And what is the length of the array? 1, 2, 1, 2, 3. It's 3. How about 1, 2, 3, 4? It's 4. What's the length of 1, 2, 3, 4? 99. Or 88, let's say. 5. Alright, so what is the min? Min is 1. And I dare you to guess what's the max. Gave you an extra second to think about it. 88. So you can round 1.4 to 1. You can round 1.5 to 2. You can give the absolute value for 1.5. Is the absolute value of negative 1.5 is also 1.5. So what is the type of 1.5? Well, what's the type of 1.4? It is a type of class, the float. So that's interesting. Now you notice when we ran these functions, we didn't import anything because they are built in. They're already imported for us, right? So we did Python -v. Somewhere along here we're going to be importing our built-ins where we get all of our built-in functions. And see, we still are running hello world because we still have that environment variable set. So here we ran, again, I forgot to show you the terminal. Python -v. it imports our built-ins for us, and we're still running. We have our environment variable set still because we did -v. It ran our hello world printed out because it ran our example.py function, because we still have our Python path startup. Right, so if we did, still running that. So moving on, we import the module from standard library modules are built into Python, but you have to import them. So you import the module using the import keyword, like import math, and then you do math dot whatever to access all the functions on the math module. So depending on your IDE, you'll see different functions available to you that you can use in your documentation. So let's have a look at some of these things in math. Math.py. And we'll also look at the random module, which has random.random and random.sample. So we can say it's standard practice to put the imports at the top. If you'll check PEP 8. Import math. And now we can say print math dot, we could say math.py, and we could give it some values. See, you can tell it, give it files, you can give it string inserted between the values. Let's try that. So we just print math.py, and let's run it. Let's see what happens. So it said hello world, and it said float object is not callable. So we tried to call math.py, but it said it's a float, and you can't call a float, so we can't use parentheses because it's not a function. All right, let's try to run it again. All right, so here's, it printed our 3.1415. This is an irrational, infinitely long number, which it just uses a few digits here. So we can also try to print out math.e. See what that does. There's E 2.7. We could say math.nan. What does that do? It's nan. Math.square root. Now square root actually is a function. So you need to give it a float, and it returns a float. Let's see what happens if I give it nothing. Error. Type error. Square root takes exactly one argument, but 0 we're given. Alright, so let's say this. What's the square root of -1? Let's see if it says anything. Value error. Math domain error. Didn't like that. Alright, what's the square root of 1? 1. And what's the square root of 43? 6.557. All right, let's try to import let's keep things simple. Let's print off random dot, what should we try? Random dot random. And just print off some random number. So there'll be a random, it doesn't really explain it here, but it should be between 0 and 1. So I get 0.2. Let's try it again. 0.4. 0.6. You get the idea. So let's try to run sample. We'll give it a range of 100 different numbers, from 0 to 100. Well, the range will be 0 to 99, and let's choose 5 of them. See what happens. So there's a list of 5 numbers between 0 and 99, inclusive. So let's try to use sysargs, argv, right? And see if we can't find out what our arguments were to our Python interpreter. We don't really know because we're using an IDE. So let's see, we said import sys, and then we don't get to show the turn on. So we say import sys, and then we're going to print sys.argv. See what happens. So we just have one argument, which is the name of the file we ran. Well, here's our executable. Here's the argv. Now, if we were to go to our terminal and we were to type in, first we will save this code. So we're printing argv, and now if we said Python minus, let's see, minus d. So we gave it no arguments, apparently. So we wanted to, because we didn't give it a file name, it didn't run our example. But it did tell us that it didn't count this. Oh no, it still ran our file. It ran right there, but it didn't have any argvs. So maybe we can run example. It should run this twice, huh? No, it didn't. It didn't run our Python startup because of the Python, but it did give us our argv. So if we ran, it doesn't give switches as they're not part of that. I didn't know that. I thought they would be part of it. And V as well. Hello world example.py. Yeah, it's okay. It's just the file name, so it's. So what if we typed in example twice? Yeah, it just gives us the file names. So it won't run the program twice. Interesting. So let's try using input. And we'll see if we can capture input from the user. So let's try. Well, we can't put that on the command line. For the shell, we have to put it into our interpreter. So let's set a variable color equals, we get the input, And these are not quotes. These are quotes. What is your favorite color? My favorite color is red. Now if I type in red, now if I type in color, red won't do anything. Now the color is red. I could also say print color. But if we're inside of the interactive interpreter, then we can just, assume that we want to print it out. So again, we set our color to the input. What is your favorite color? And then we can print out the color. Red. We can also open text files, write to them. That's exciting. But this video is getting a little bit long. I'll leave that for you as an assignment. And I'm going to just leave it there. So that was using Python. And if you want to join us in the next class, we'll be talking about language fundamentals. All right, that's it. Thank you.